The Embassy office building features an airside economizer that provides free cooling during the shoulder months, thereby reducing wear on mechanical refrigeration equipment and minimizing substantially building annual operating cost. Aside from energy savings during shoulder months, this vital subsystem manages indoor air quality when properly configured with carbon dioxide instrumentation, a process called demand control ventilation. More on this feature later. Airside Economizer employs an outdoor air intake damper, a return air damper, ventilation damper, and 2 relief dampers, one on either side of the return air chase. Existing air control dampers are beyond their useful life. Broken and binding side seal bearings do not allow smooth, low-torque operation. Therefore, pneumatic actuators cannot overcome friction to smoothly modulate airflow. Dual-purpose side seals minimize leakage while also serving to reduce friction. Naturally, failed seals mean dampers can't tightly close without assistance, thereby allowing undesirable and costly energy to condition excess outdoor air. In the following video, I dynamically test air control dampers by commanding dampers between full open and then full closed. Notice how dampers cannot operate without manual assistance. For simplicity, I recorded the west side relief damper assembly only. This damper and its counterpart on the east side are normally closed. If able to operate automatically, relief dampers would manage building static pressure. This is an important security issue because excess building pressurization prevents exit doors from fully closing. Finally, demand control ventilation, DCV. Carbon dioxide is a naturally occurring mineral consisting of 1 oxygen atom bonded to 2 carbon atoms. It's found in our air and surface water. Not a pollutant, CO2 is a product of cellular respiration, breathing. We mammals exhale CO2 and inhale O2. Plants inhale CO2 and exhale O2. It's a great symbiosis vital to all life on Earth. There is a direct and linear relationship between actual building occupancy and CO2 concentration. CO2 concentration increases as building occupancy increases. As CO2 concentration rises, we modulate economizer dampers to dilute indoor air with outdoor air. As people leave the building, CO2 concentration rapidly diminishes, so the control system reduces toward zero the intake of outdoor air. Demand control ventilation is in play year-round. Naturally, while the air handling unit airside economizer is enabled, CO2 concentration will closely track present outdoor value. ASHRAE 62.1 prescribes ventilation management, including the use of CO2 measurement applied as demand control ventilation. To incorporate this excellent proven technology, only a carbon dioxide sensor need be added. Energy efficiency and excellent indoor air quality are not mutually exclusive. A well-controlled building is also an energy-efficient building.